This is lesson 3.1 on algebraic expressions. Before watching the recording, you may want to have a graph sheet of paper in front of you and a pencil to record some notes or to do some of the problems. So please feel free to grab those items now. And I'm going to continue. So if you remember from last year, algebraic expressions are representations of a numerical pattern. And usually you would have a combination of numbers, one or two operations, and letters, which we refer to as variables. So now what we're going to do is we're going to put this all together and think about how it relates to word problems. So that's what we're going to do first. And then we're going to get into the definition of the different parts of an algebraic expression, and then we'll go through a few more examples. So let's get started here with the first example, or the first problem. So now here in this situation, we have someone named Doug, and he washes dishes for a living. So he earns $25 a day for doing his job. Now, in addition to that, he gets a bonus of $2 per dish. So the question we want to ask is, how would we calculate the money Doug would make if he washes, say, 75 dishes? What I'd like you to do now is pause the recording, look at the situation, look at what the information you have in front of you, and figure out how you would calculate how much money he would make in that situation. Now, I don't want you to solve it. I want you to figure out the operation or expression you would use to figure out how much money he would make. So now I'm going to continue. So what do we know? What do we know? We know that he earns for sure $25 a day. That is always constant, okay? We also know that he earns $2 per dish. I see a connection here because he has washed 75 dishes. Somehow these two have to be connected. Well, if he earns $2 per dish and he washes 75 dishes, it would naturally be 2 times 75. $2 per dish. He washed 75 dishes, so you'd have to multiply that. But what you also have to keep in mind is that he still earns $25 a day, so you have to add that on top of your total there. So that's the expression we would use to calculate how much money he would make if he washes 75 dishes. Now notice I didn't figure out the answer. I'm just thinking about the process and figuring it out. Now, the next situation is, well, how much money he would make if he washed 84 dishes. I'd like you to pause the recording and figure out how you would figure that out. So now I'm going to continue. Same thing. I know there's a connection between the amount of dishes he's washed and the amount he earns per dish. So it's probably most likely going to be the same process. It's going to be $2 per dish multiplied by the number of dishes he washed, which is 84. But we're not finished yet because we still need to consider that he earns $25 a day for doing his job. So we know that's what we come up with. Now finally, how much money would he make if he washes 25 dishes? Again, I'm going to look at the amount of dishes he washes, the amount earned per dish. I'm just going to write it up here. We know it's going to be 2 multiplied by the amount of dishes he washed. Now again, he earns money for doing his job, so we have to add the $25 because that always stays the same. So those are the 3 expressions. Now what I'd like you to do is pause the recording and figure out, what do you see in common amongst these 3 expressions? Again, what do you see in common amongst these 3 expressions? Okay, well, I know that you're always adding 25 each time, so I'm just gonna box that out here. We know that each time you're adding 25 because that's consistent with how much money he's making. And then I also know that he is also earning $2 per dish. Okay, $2 per dish. Okay, now we know we're multiplying by 2 each time and we're adding 25 each time. But also something to think about is, what are we multiplying by 2? Well, it's always going to be different every time. So in this case, it's 75. In this case, it's 84. In this case, it's 25. So we could say that it varies every time. So we know that it's going to be 2 times the number of dishes Doug washes, right? So could we generalize that by using a letter in its place? Sure we can. It's going to be 2 times n. N represents the amount of dishes that Doug washes. That's how we substitute it and represent it as a variable. On top of that, we can generalize it by saying that the algebraic expression is 2 times the number of dishes, which is 2n, adding 25. Because 25, as you remember, he always earns $25 per day for doing his job. So that's how we come up with the algebraic expression. Okay. So back to this. So the basic algebraic expression. So notice I flipped it around, but it's essentially the same thing. I know on the other slide it was 2n plus 25, but again, it does mean the same thing in this case because we have addition, okay? So it has the commutative property if we flip it. So just going through some definitions here. The n represents a variable. Remember, it's a letter representing an unknown number. And it always changes. That's why it's called a variable. An unknown number. Okay, so whenever you see a variable, we know that that represents an unknown. Next, it's the numerical coefficient. So a numerical coefficient is defined as the number multiplied by the variable. Okay. Again, the number multiplied by the variable is the numerical coefficient. Now, what's important to note is if the numerical coefficient is 1, you won't typically see it. So if this expression was just 25 plus n, it's implied that it's 1n, but we would typically not write 1n, we would just write n, okay? Finally, the last part of an algebraic expression is called the constant term, okay? The constant term, oops, what happened here? Okay, I might have to go back. What happened? Okay, 1 second. Okay, sorry, I just lost all my writing there. Okay, the constant term, we refer to that too as the part of the expression. It does not change based on the value of the variable. If you missed some of those notes that I just lost, I would invite you just to pause the video and then just replay and go back and replay those parts that you missed. Okay, so we've got the variable, which is n. Remember the variable, the numerical coefficient, and the constant term. So make sure you're familiar with those 3 terms. So what we're going to look at now are examples of algebraic expressions. What I want you to think about is what each of these algebraic expressions means in terms of words so we understand how to build them. So we'll do the first one together. So we've got the variable k minus 3. So what you could do is you could think about the order in which you would express this. We could say this is 3 less than a number. We could say a variable decreased by 3 or the number k decreased by 3. It's up to you, but we have 3 less than a number here. The next one here, we've got 6 multiplied by a number or 6 times a number. Remember that a number represents the variable or the unknown. Another expression we have here is a number divided by 4 here, or Yeah, a number divided by 4 would probably be the best way to describe that. And finally, we've got 7 more than 5 times a number, which would be 5b plus 7. Okay, or you could also say a 7 more than a number multiplied by 5. That's also an acceptable way. So make sure you're familiar with how to interpret not only an algebraic expression, but also be familiar with how to write an algebraic expression given what it means in words. Finally, the last slide we're going to look at is going back to Doug's expression again. So say, for example, we know that he's washed 207 dishes in one day. Okay, remember we're going to use the same expression 25 plus 2n that we came up with on the first slide. Just as a reminder, the 25 represents the $25 per day that he's earned. The 2 represents the $2 per dish. Now in this case, n is actually equal to 207 dishes. If you remember on the previous slide, because n is the variable it always changes, we can always substitute it for however amount of dishes is given. So we're going to evaluate this now and figure out how much money he actually earns by washing 207 dishes. So what we're going to do is we're going to apply BEDMAS. So you remember that's the order of operations. So just to recall, we've got brackets, we've got exponents, and we still have to apply this order. And then feel free to fill in the rest of this on your own. You can pause the recording and do this yourself. Multiplication, multiplication, I can't fit it all in here. Addition, and subtraction. Now remember levels of operations. So remember, division and multiplication are considered one level of operation. So if they're the only ones left, you solve it left to right. Same thing with an addition and subtraction. If they're the only ones left in a sentence, you solve them left to right. So they're considered another level of operation. So let's go back to here. So we've got 25 plus 2n. My n's disappeared again. We're going to substitute the next line first. Oh, sorry, it's jumped ahead. So the next line would be 25 plus 2 times, remember that you have to show your substitution in brackets. In this case, it's 207, okay? Now, remember that according to order of operations, you need to solve the multiplication first. So you're going to solve 2 times 207. You can do that off to the side. I'm sorry, it's already appeared. And do that work to the side. The next line should be written as equals 25 plus whatever the answer is to 2 multiplied by 207. So we know it's 414. And then the final line you're going to add 25 plus 414, and that gives you a total of $439. So remember, you have to apply the order of operations here when you're evaluating expressions. Even though the multiplication appears second, you have to solve it first according to how it appears in the order of operations. So, in summary, we've talked about algebraic expressions, how to build them. We've talked about different types of algebraic expressions that you can see using various operations. We've also talked about BEDMAS, or the order of operations that you have to apply when you're asked to evaluate an algebraic expression. Whenever it says evaluate an expression, that means that you're taking a value and you're substituting it in for a variable. So in this case, it was 207 that we substituted for n, which equaled the number of dishes. Okay, and that is it.